Okay, good morning all. So let's start about today's session. So today's sessions are going to be about agentic AI. And for first session, we have a speaker with us, Dr. Abhijit Thakre sir. Let me introduce with him first. He has over 20 plus years of experience in research, leadership, and innovation. He has industry experience in various industries such as Harrier Information Systems, Geometric Limited, ITC Infotech Bangalore, and currently he's working as an AI architect at Soft Clouds. So, on behalf of Triple IT Nagpur, sir, we welcome you and hope participants will get maximum out of your sessions and industrial perspective of AI.
Yeah,
So,
thank you so
over
much.
to you, sir. You can
Yeah,
continue.
yeah. Thank you so much. Give me 1 minute. So thank you, Nilesh sir, for a nice introduction. It was very glad to meet you all from after a long time. And thank you, participant. So we will start the presentation. You can see my screen, my PPT.
Yes, yes, it is visible, sir.
Yeah, the PPT is visible, right?
Yes, yes.
Yeah. So our topic we will cover today is agentic AI, the next wave of intelligence. We will see today what are the different agentic AI systems what are the design patterns in agentic AI, what is MCP, what is A2A protocol, how they work internally, and how we can utilize to do our work, open-ended problems for open-ended problems. So that is the main thing. So we'll start with the agentic AI session. So everybody is not everybody is talking about nowadays about the agentic AI system, but really, what is agentic AI and how the agents work, that we will see today from the core, how the agents really work and what are the AI agents first. So we are having different flavors in our presentation. So first we will start with what are AI agents. So nowadays, if you can see from last 3-4 years, everybody is hearing about different kinds of models like GPT models, large language models, Mistral, Llama, everything. So initially, three years back, 4 years back, people was utilizing these models. People start utilizing these models to do their work. They ask a questions or a prompt to that model, and a model will generate the answer either using internal knowledge or based on some injection of the external knowledge, which is called as rack systems. So everybody is aware of that rack. If not aware, we will have some glimpse of it in the coming slides. So 3-4 years back, everybody was talking about large language models and they are utilizing LLMs to do their work. But it's like a close end loop. You can say close end loop means you ask a question to the LLM will give answer. There is a no refinement, there is a no correction in the answer, there is a no agents involved. If you are having a multiple task, that multiple tasks are not split up for every agents. Okay, agents will not think, it will not react. In that case, you just ask a question, it will give the answer based on its internal knowledge, or you can say whatever the knowledge we inject to it. So first we will start what are AI agents. So naturally AI agents are built on top of LLMs. My voice is audible, all of you?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
So the core of AI agents is LLM. That is, we have to keep in mind that LLM is the core of AI agent. Without LLM, we can't imagine the AI agents. Okay. So basically, AI agents are software entities which utilizes LLMs. That is the core. and which also do some planning and action with bounded scope. Now, what is the meaning of bounded scope? The bounded scope means the goal is decided, what to achieve. That is called as bounded scope. Okay. We will come with some use cases whenever we see a MCP or A2A protocol. So what the AI agents will do? So the AI agents will not answer the questions whatever the user will ask, but it will observe the context, reason about the goals, and it will decide the next actions. Okay. And it will call some tools also. So the tool calling is one of the important aspect in AI agents. So without tool calling, you can't imagine AI agents. Okay. Now, what is tool calling? We will gradually see in the coming slides. Okay. So whenever we see a agentic behavior, which comes from the iterative loops, like it will think. It's not asking a question and getting the answer. It will think it, it will act it, and it will reflect it over the first answer, second answer. It's kind of, you have seen a deep learning different frameworks in which we refine the answer with the help of feedback loop. Okay, we reduce the error rate. In the same way, AI agents will behave. They will, whenever first answer is generated, it will, before generating that answer, it will think it, it will act over it, and when the answer is generated, it will refine the answer, it will correct the answer, and then the error rate is removed in every iteration, and you will get a more accurate answer when the final answer is generated. Okay, so we have LLMs as a AI agent, it which will perform the actions. Now whenever we say a action performance, there is a tool attached to it. So whenever we say a AI agents will perform action, it will call some tools, so it will access some tools, and it will access some knowledge. Okay, so what is this? What is tools? What is actions? We will see gradually. So there are different types of AI agents. Okay, there is a not only one type of AI agents. These are different types, like simple reflex agents, which will perform immediate actions based on predefined rules. Okay, so the meaning of this is you have to tell the AI agents with the help of instructions that what he has to do. Okay, so that is called as rules. So you have to feed the rules to the agents with the help of instructions, and it will perform immediate actions based on the predefined rules. So that is called as simplex reflexive agents. There are some model based reflexive agents, as you can see in the PPT, which will perform actions based on the model of the world and change to the model, means based on the situation of the world. We will see one example for this. There is a travel agent which prioritize routes with significant price changes based on access to historical pricing data. So it will adjust the price changes based on the historical price data, and it will follow that route. Okay, so there are some goal based agents also. There are some utility based agents, learning agents, hierarchical agents, and multi agent, which is very important. We will come to that part, multi agent. So based on your use case, which agent you want to utilize in your framework, that will depend. So nowadays everybody's asking about AI agents. Okay, can I use AI agents in my software development? That is the first question. Okay, so not in every situation you have to use the AI agents. When there is a open-ended problems, okay, multi-step processes, and when there is a improvement, we want to improvement over our solution over for our solution over the time, then we can use the AI agents. So it's not only that in every situation like a close-ended problems we can use the AI agents. It is used in three situations: open-ended, multi-step, and when we want the improvement over the time. So there are some problems like if you take any use case or any problem to solve which requires multi-step reasoning or which requires access to different tools. Now what is the meaning of tools? Tools plays a major role for accessing a data from various resources. Okay, so whenever we have one tool access to weather data, another tool access to travel data. So these are tools. So tools play a major role for accessing the knowledge data and injecting it into the AI agent. So whenever your problem requires a multi-step reasoning or a tools or a decisions, not as a one-shot completion, then you can use the AI agents. And there is autonomy also. Like autonomy plays a major role in this scenario. Like whenever the system will decide in this case what to do next based on the intermediate results. So whenever we build any solution based on the AI agents, there is some workflows attached to it. So workflows are like a predefined steps. It's kind of algorithmic way that do this step first, then do this step, then do this step, and then you will get some answer. So it's a multi-step processes. So in workflows also, simulation of the workflows, automation of the workflows, process workflows in any organization, in any industry, we can use AI agents where the multiple steps and predefined steps are required. And the last point is you can encapsulate complex behavior behind a stable interface for apps or users. So whenever there are complex behaviors you want to simulate, you can use the AI agents over it. So it means that AI agents are not only used as a core as an LLMs. So LLMs are the core, but there are different things like actions, tools, and knowledge. Different types of agents we have seen. And when there is an open-ended problem or a multi-step processes in which you want to refine your solution over the time, then you can use the AI agents in that scenario. Any questions up till this point? Okay, fine. If you have any questions, please free to ask. It should be interactive session, what I feel. Yeah.
Sir, I have a question.
Yes, yes.
Sir, when we use this chat GPT,
Huh?
uh, can we say that they are using AI agents? Because
Yeah,
based on the situation, they keep on changing the answer. If I ask previous question and connected to that, if I ask another question, they correlate to those two questions and
yes.
then they answer.
Yes, they are internally using some AI agents because they
Okay,
maintain some memory also. They maintain some
okay,
context memory like short-term memory, long-term memory, episodic
huh.
memory. We will come to that part gradually.
Okay, okay,
So
okay, okay. Because
definitely, it is a contextual understanding that based on the context or based on the previous history, you can ask a question. So definitely, they are using
yes, sir.
the agents. Yes.
Okay, okay.
Yeah.
All right. Thank you.
Uh, Good morning,
Yes.
sir.
Good morning. Good morning.
Sir, I have a question.
Yes.
Sir, my question is that actually, sir, I am a PhD scholar.
Haha.
Then I learn machine learning, deep learning. Now I am learning LLM.
Hmm.
Then
Hmm.
what is my next move? I think agentic AI is a next move.
Yeah, but moving to the agentic AI, you should know the basics of agentic AI before coming to the agentic AI. You should know LLMs, the basic of LLMs, and LLM's base is natural language processing. So you should have a good understanding of NLPs, like what is tokens, what is uh, what is dependency parsing, what are the different libraries in NLP like SPACY. Okay, how they do a dependency parsing, how they find a relationship between the words. Okay, all these things you have to know in detail whenever you go move to the agentic AI.
Oh, okay, sir. Sir, in this session we learn and make a agentic AI.
Yes, we are going to learn the basic core things of agentic AI, how the agentic AI will work, different design patterns, MCP A2A protocols.
Sir, any hands-on workshop? Uh,
Uh, in this session, this is very 1.5 and 2 hour session. For hands-on, we require one workshop. I can take that workshop for agentic AI for the hands-on, no issues. But here
okay,
the main objective is you should know how the agentic AI system works, what are the design patterns, and then you can go for the implementations.
Yeah. Okay. Thank you,
Yeah.
sir.
Yeah. Thank you. Any more questions? Okay. Thank you. So these are the basics. The basic is core loop, basic of agentic AI system. Observe the context. Okay, context means whenever user asks a question, find out the intent from it. What is the context or intent from it? Reason and plan. Okay, act via tools. Act via tools means, see, reason and plan is an activity done by the AI agent. Act via tools is also activity, but here the tool calling is actually done. Now, tool calling means extracting the resources or a knowledge base from various things. Like if there is a web services API, you will extract the weather data from one of the tool. If there is a share market API, you will extract the share market information from one of the API. Okay, so this has happened with the help of tools. Okay, then there will be a evaluation actions, and after evaluation, if there is an error or you want, or if the AI agents want to refine your answer, then you will repeat this process as a core loop. Okay, now here the important part is grounding. So everybody heard about hallucinations in AI agents, or you can say LLMs. So these hallucinations can be avoided through grounding of the enterprise data. So you have to provide a valid grounded data to the AI agents via a different tools. So there are different mechanisms like a RAG, SQL, APIs. So whenever we say APIs, tools will call that API. Tools will also perform the RAG also. We will see all these things. And there are some domain related tools. So this kind of operations plays an important role in grounding. Grounding means giving the right data or a right enterprise data to a AI agent so that it will not hallucinate. It will not assume the answer or generate the answer from its own. It will refer to the grounded data and then generate the answer. That is the best way to avoid the hallucinations, right? So use the next thing is, whenever you are using a agentic AI solution, you should use various policies and guardrails. Now there are different types of, what do you mean by guardrails? Guardrails are security measures. There are input guardrails and output guardrails. So if anybody asks a invalid question, please tell me how to do a robbery in the bank. So there should be some input guardrail so that the guardrail will just filter out your question based on your intent, and it will not pass that question to the LLM and give the response that please ask a valid question, or I am not able to answer this question because of this policy reasons, something like that. There are some output guardrails also, like LLMs. There are some small LLMs also. They generate very, you can say, unsafe answers. So before sending that answers to the user, there should be output guardrails. So whenever the unsafe answer is generated by the LLM, then it should not shown to the user. Okay, there should be output guardrail which will filter out that unsafe answer and show a proper answer to the user, that this this is not anything like that, some message or any message to the user which will tell that this answer is not safe. Okay, because there are some small LLMs which will generate the unsafe answers. Big LLMs, they are very good. So there are different kinds of guardrails like prompt injection guardrails, topical guardrails. If you ask, if you are developing an agentic AI system and you create one agent, and if you are asking a question outside of your topic, because the agent is created for a particular topic only, for a particular domain, it should answer the question for the particular domain. And if you're asking a question out of the domain, it should give the topical guardrail will come into the picture, and it will say that this question is out of the topic. Please ask a proper question for the particular domain. So in this way, there are safety guardrails, there are topical guardrails, there are PII information guardrails, security check guardrails, different kinds of guardrails which we have to implement. This is not automatically done. We have to implement whenever we are building our agentic AI system. We have to define our own policies also. Authentication policies, authorization policies. Okay, all these things we have to apply whenever we are building our agentic AI system. We have to log the actions and decisions for transparency, debugging, and governance. So these things should be considered for ethical considerations, for security check, because nowadays these are very important. Only implementing agentic AI system is not important. You have to implement the policies, you have to implement the ethical policies, guardrails, security measures, PII masking information. Like suppose anybody, if any questions is related, is having a information of a Aadhaar card number of a particular user, that Aadhaar card number should be masked by the agentic AI system, and then it will go to the LLM. So we have to implement this kind of scenarios whenever we are building our agentic AI system. And then agentic AI system will generate the answer with that mask Aadhaar card number, and then your agentic AI system will replace that mask Aadhaar number with the original number, and then show that answer to the user. So you are not supposed to pass the sensitive information to the LLM, okay? Because the data nowadays is very precious. So everything is revolving over the data nowadays. Agentic AI system, if you give a right data to the agentic AI system, it will work fine. Also, the data security is most important concern nowadays to the various IT industries doing R&Ds in agentic AI system, or those who are implementing the agentic AI system. So they want that their data should not go to the third party. Like if you are using a subscription model of GPT, any model 5.4 or 4.2, and you are sending all the data, even if OpenAI says that they are not using their data for the training, but we don't know what they are doing, right? If you are using your in-house LLM or open source LLM, that we can guarantee that you are using that LLM in your infrastructure for building the agentic AI system, then it's fine. Okay, but if you are using any data which you are passing through a API to a different OpenAI models, we can't guarantee. Okay, so nowadays these are very important: security guardrails, security, data security, PII masking, sensitive information should be masked. All these things we have to implement in our agentic AI system before not only just implementing the agentic AI system, but with all these features. Yeah, sorry. Yes, any questions up till this point? Okay, thanks. So first, now we will come to the agentic AI design patterns. So what are the design patterns? So first pattern is, now what do you mean by design patterns? The design pattern means based on the use case or based on the scenario, what are the different ways you can implement the agentic AI system? So first pattern is reflection pattern. So what you can see in the diagram, there is a user who fires a query to the LLM. Okay, and LLM will generate the answer. Okay, initial output is generated, but LLM will not give a one shot answer. It will iterate over that initial output and find out any mistakes over it, and then that is called as LLM reflection, and then it will resolve that mistakes and generate the final out. So this is called as reflection pattern. So it's not a one stroke process that LLM will generate the answer and stop, like what you are doing. Like whatever you are doing, you build any chatbot using LLM, you ask answer, you get an answer, you ask a question, you get an answer. Not like that. It will reflect over that particular first answer and then generate the output. So it will correct the mistakes and produce the final answer. So this is reflection pattern. Second pattern is tool use pattern, which is very important nowadays, and everybody is using this pattern. Okay. So what is tools? Tool allow LLMs to gather more information. So basically tool, what do you mean by tool? So see, basically if you see a real world use case, what do you mean by tool? I have a tool for doing this actions. I have a tool for doing that action. Software tool, hardware tool. Okay. So what is tool? In LLM case, tool is basically used to extract the grounded data from various resources. Okay. So it can be either a vector database, it can be APIs. So there are different APIs, weather information API is written, stock market information API is written. So all these APIs will fetch the data from the different resources and provide the data to the LLM as a grounded information. Okay. So there are suppose 5 tools here. Okay, 5 APIs, consider the case. Now LLM will decide from that five tools which API to call based on the intent of the query. So that we have to design whenever we are building our agentic AI system. Whenever the query comes, it will find out the intent. It will classify that intent into particular domain or topic and then call that particular tool. So that is the tool calling. So tool calling is not only API calling. It can be a executing Python script. API is one of the major use case, but you can call any Python script. You can call a vector database. You can make a call to vector database. Everybody is aware of the vector database. Okay. Hope so. A vector database is it's not a normal database. You can store the embeddings into that vector database for getting the most semantic uh, chunks for the particular questions. Okay. So you can say whenever you have unstructured data, you can't store that unstructured data, all data into your normal database like SQL, Oracle. Okay. There is a specialized database that is called as vector database, in which you will store that unstructured text data in the form of small chunks, but not as a text data but as a embeddings. So embeddings are numbers. Okay. So embeddings play an important role because machine understand embeddings, they don't understand text. So whenever or if you have a big paragraph, you chunk it into 100 chunks, and all for every chunk there will be multiple embeddings also, and you store all that embeddings into the vector database. Now whenever you ask a question, the question is converted into embeddings, and then the most relevant chunks is extracted from the vector database and then that chunks with the questions will go to the LLM for generation of the answer. That is the RAG. Okay. Retrieval augmented generation scenario. So tool calling is not only based on APIs, it should be based on vector database. It should be based on invoking a Python script. And then this will be a grounded information provided to LLM, because if this is not called, consider the case that this is not called, what will happen? LLM will generate the answer based on its internal knowledge, whatever it is trained, right? Okay. So suppose I will give you one example. Um, you are running any software company and you have some HR policies designed having 100 documents, right? Now if you and that documents are not published on the web, now if you ask to chat GPT a questions over that documents, it will hallucinate because the information is not grounded, because that is not published. Okay. So that's why companies are moving towards, and you can't upload your document over chat GPT because that will be again a security concern, right? Like many of the big organizations like government organizations like DRDO or health ministry, they just banned ChatGPT. Why? Because they are building their own agentic AI system, their own chatbots, which will perform the RAG mechanism internally, and they will have their own LLMs, and then the data will be secured. So if you ask a question to ChatGPT over your HR documents which is not published over the internet, then it will hallucinate. It will not give the right answer, right? Because that is not having a grounded information of your documents. But if you upload it, then if you ask a question, it will give the right answer. But there is a security concerns, right? So that's why we have to provide the data. If you are having a data and this is your local infrastructure setup, then you have to provide the data to your local or open source LLM with the help of some tools or vector database, and then it will generate the answer over this data. Otherwise it will generate the answer for based on its knowledge only, right? So then it will generate the answer and then it will give the response. So this is the tool usage pattern. So first pattern we have seen is reflection pattern. It will generate the answer. There is a no tool usage. It will generate the answer based on its knowledge, but it will iterate over that answer and correct the answer, right? But here the grounded information is provided with the help of tools and APIs so that LLM will get the latest updated knowledge for which we are building the agentic AI system. Okay, so this is called as knowledge injection. So this is one of the use case called as knowledge injection, in which you inject the external data to the LLM and then LLM will generate the answer. So this is called as tool calling. Any questions up till this point?
Sir, in the previous slide, you had
Yes.
you had showcased something called a reflected output.
Yes. This one.
Please explain what is that exactly.
Hmm. Reflection means whenever you generate the first output, it will correct it. It will correct it using different techniques based on the different scenarios and based on the instructions to which instructions whatever you feed it to the LLM, it will correct it and it will remove the error in every iteration and generate the final output. That is called as reflection. Now why it is called as reflection? Because it not only generate the first output and consider that it is a final output, it will correct the output, remove the errors, and move that output over every iteration. Like we have seen the epochs, like you fine tune the LLMs, right? You heard about the word fine tune the LLMs. So what you do
Yeah.
in fine tuning the LLM, you fine tune the LLM over every epochs, and you remove the error rate. In the same way, this reflection pattern will work. I hope you got your answer.
Yeah, thanks, sir. Sir, but one follow-up question. How does it
Yes.
know how much is the error or what is the error that it is improving on?
Yes, there are different techniques for that. We have to implement that techniques using our Python coding and other scenarios. There are different algorithms for that, through which we can it can measure, or we can train the LLM, or we can fine tune the LLM that what is the error rate and other things. Yeah,
Okay, thanks, sir.
yeah.
Good
Thank you.
morning, sir.
Good morning.
Sir, my question is, sir, what is the difference between RAG and Agentic AI?
RAG and
Agentic AI.
see, RAG is a mechanism in which you provide the grounded data to the LLM so that it will not use the its internal knowledge and generate the answer. So this is a RAG. Okay, you provide the grounded data with the help of various APIs and vector database to the LLM. Agentic AI is the overall system. RAG is one of the part of it, right?
Yes, sir.
Did you got the
Sir,
answer to your question?
can I can we make RAG or Agentic AI?
Yeah, you can implement RAG as a agent as a part of agentic AI system. There is a one concept called as agentic RAG. We will come to that particular part.
Sir, my last question is, sir, what is the uh, basic system requirement to implement RAG or Agentic AI?
Yeah, you should, if you want to use a RAG, or if you want to use a implement agentic AI system, you should have a good infrastructure. If you are using open source LLM, okay, you should have a GPUs, you should have a good hard disk, good memory, okay, and good infrastructure. You should have a dedicated machine. There are various ways. This is one of the way. Second way is you can use a subscription. If you're using a subscription based model like GPT or other things, then you don't need an infrastructure that much. And the third way is cloud based subscription. Like you will get a space in the cloud. If you're using AWS Bedrock or Azure or any other things, you will get a space in the cloud, and then you can deploy your LLM there, deploy your Python code there, and implement the agentic or rack system, right?
Yeah. Okay, sir. Thank you.
Yeah. Hope it answers your question. Okay. React pattern. Third pattern is React pattern. So what do you mean by React? Just see the diagram. React combines the above two patterns, like whatever we have seen, reflection and tool calling. So it combines two patterns. Here it is improving the answer over every iteration and also do the tool calling. So your final response will be a reflection of, or you can say most filtered outputs based on the grounded information via tool calling. So this makes very most useful pattern, and this pattern is, you can heard about this word React. Okay, so this pattern is, everybody is using this pattern nowadays whenever they are building an agentic AI system. Now, one thing I missed answering to the last question, why we need a GPUs? Because we are using LLMs, and LLMs are very big. Like you can't run the LLM. You can run the small LLM on your laptop. Okay, 0.5 billion or 1 billion. Okay, but the LLMs which are very big, which requires a huge space and good processing power. So that's why we require a GPUs. Okay. So coming to the point, so this React pattern will is a combination of two things. One is first thing is reflection pattern and tool usage. So it refines the answer, final answer over the iteration, and also do a tool calling. So naturally, whenever we are doing a tool calling, okay, you may involve a RAG or not involve a RAG. Whenever you are involving a RAG, vector database will come into the picture, because you are storing the vector embeddings, right? But there are some situations like you call directly a tools, fetch the data from it and pass it to the LLM, not storing into the vector database. But that is a bad habit, or you can say bad practice. You should store the data into the vector database. So vector database is a part of this particular scenario also. That is most important, even if it is not mentioned here. So this is one of the agent, right? So this will perform some action, calling some APIs, calling some tools, gather some environmental data, and generate the results. Yeah. The next pattern is planning pattern. So planning means, suppose you have a open-ended questions and it involves a multiple steps. Okay, first step, second step, third step, and then generate the final output. So there should be a planner, which is a part of agentic AI system, which will generate the task. Okay, what task should be executed, and then the single task is executed. Maybe not only single task, all the, if there are some parallel things, agentic React agent will execute the parallel task also, generate the results. If the parallel task results should be accumulated at the end, that can also be done by the React agent, and then it will generate the final answer. So in the planning pattern, the planner plays an important role for execution of the multi-step task to achieve the final results. it will do first a planning. Okay. Now, if the task is not finished, it will again go to the planner. Planner will generate a new task. And then that new task will be executed by the another React agent or same React agent. So there may be a multi-agent scenario in planning pattern also based on your use case, whatever you want to do, how you want to execute, or what is the use case. Based on that thing, you can change the planning pattern either to multi-agent or a single agent. Okay. Now this is a multi-agent. So in multi-agent patterns, we have several patterns. Like we have a PM agent, we have a DevOps agent, tech lead agent, SD agent. Now when we use a multi-agent pattern, when we use a multi-agent pattern, when each agent is dedicated for a particular execution of the task, and each agent is having access to some specialized tools. So here it is not mentioned, but you can say, if you refer this tool pattern, this is one agent. Okay. So it is every agent is having a LLM and tools that you have to keep in mind, that every agent is having a backend as the LLM and a tools or a vector database or a rack system you can implement inside one agent. So in a multi-agent scenario, this agent can access is having one LLM as a dedicated LLM, either open source or a subscription based model or whatever the case. And it will have their tool calling mechanism or a rack based mechanism inside it. And each agent is dedicated for a particular role or a task. When that task is completed, it will pass that output to the next agent. It not only it will pass the output to the next agent. So sometimes there are some two agents working parallelly also. So there should be a handshake between two agents also in the delegation of the task. So some task, suppose tech lead agent execute one task, it will, and there is something which is dependent on DevOps agent. It will delegate that task to the DevOps agent, and then the DevOps agent will complete that task and again pass a control to the tech lead agent, and then the tech lead agent will give the control to the SD agent. So it's not only the case that one agent will execute the task and the first agent completes it. There are some parallel activities also. Okay. Or there is a delegation of the task also. And then the final response is produced when all these activities are done. So this is a multi-agent pattern which is commonly used nowadays in the industry for implementing the agentic AI system. Just a minute. Yes, any questions up till now? Yeah. My voice is audible. Okay.
Yes, sir. Yes, sir.
Okay. So multi-agent plays a major role in the industry nowadays because of the open-ended problems, multi-step reasonings, multi-step processes. Every agent will take a control of their own task as a dedicated role manager. And then lastly, all agents work together to deliver the final outcome. That is the main thing. Okay. If anybody is not having any questions, we can move to the next slide. Okay. I already spoke about the tool calling. Okay, but still we will have what do you mean by tool calling? We have seen only vector DB and APIs, but there are some local file systems and browsers that plays another tools. Like these are tools. Vector DB is a tool, API is a tool, local file system is a tool, and browser is a tool. So from these tools, we get a grounded data to the LLMs. So basically, tool calling is a extension of LLM capabilities for searching, code executions, or APIs. And there is a loop of LLM call, tool calling and LLM calls, which supports a complex reasoning with real data. So this is the grounding of the data. And then within this tool calling, you can embed this tool calling functionality into different kinds of flavors of the agentic AI design. Either you can put this tool calling in multi-agent, either you can put tool calling in planning of the patterns, a planning pattern. Already there is a in the React, we are having a tool calling, and this is already a tool calling. So you can put the tool calling functionality in the planning pattern or multi-agent pattern. And you can use a strict validation and error handling for safe, reliable tool execution. This is very important. What is the meaning of this? Error handling for safe, reliable tool execution. So the meaning of this is, whenever you make a tool call, suppose you created any API, okay, so that there should be proper security measures. Whenever you are calling a API, there should be some authentication token generated whenever you are making a API call. Okay, because if you make that API public, everybody, and if it's your own API, and anybody can call that API and gather your data, right? So you have to put a proper authentication headers, authorization tokens for that particular APIs, so that a particular authorized user who logs into the particular system, into the agentic AI, can only call that API. Means whenever agent will call that API, and if that particular user logs into that agentic AI system, which is a valid user, only authentication is given to that particular user. Whenever he fires a question, then only he will call that API, which is provided through various mechanisms, which is called as authorization, authentication, JWT tokens, Azure tokens, AWS tokens, all these things. Yeah, so these are various security measures we can implement whenever we are building a agentic AI system. Any questions up till this point? Okay. Now the most important part is agentic RAG. So somebody asked a question, what is RAG and other things? Okay. So agentic RAG, basically what it do, RAG, everybody knows it, grounding of the information, but we put the RAG mechanism into the agentic AI system. So if you see this diagram, a user fires a query, it will go to the LLM analysis model. Okay. Then there is a check, like more information is needed. There are lots of tools here. We will select one of the tools. Means agentic AI system will select one of the tools, and then after the tool selection, result is generated. First round of result is assessed, it is corrected, and again went to the LLM. Okay, there are different techniques through which you can filter out the results or make it more accurate. Okay, so if you can see this system, and if no information is required, it will generate the final response. So if you can see, it is different than traditional RAG. So it's in traditional RAG, what happens? There is a fixed retrieval generation pipeline. What do you mean by retrieval generation pipeline? You retrieve the data from the API, store it into the vector database. Okay, fetch the relevant chunks, send it to the LLM. This is the fixed pipeline. But here, based on the selections, like there are tools, we will come to the scenario what do you mean by MCP and A2A, where you can publish your tools into the MCP servers. At this point, if this is a MCP server, that is another scenario. But whenever we get a first round of results, we can assess that results, we can correct that results, and again go for the LLM analysis. So this process will go on until we get accurate results, and this is a continuous process which is a part of React scenario. Okay, and it is a step-by-step reasoning in which the results are assessed and corrected in every step. So we have to keep in mind whenever we are implementing RAG, tool plays a major important role. But when to call a tool, that is done automatically. That is not done by user. That is done by the agentic AI system. If there are 100 tools published, which tool to call, that is based on uh, what is the intent of the question. Okay, and based on that intent, it will call the particular tool or actions. Okay, more refined agentic RAG tool integration you can see here. This is the one of the industry use case. You can see, if you see this is a tool selection. There is a single block. But now if you have a tool selection, there are various tools. Which tool to select? That is decided by our agentic AI system. And then it will gather the results, verify quality, good quality, process results, update the memory. Now here the memory plays a very important role, because you have to store the questions and answers into your memory. There are three kinds of memory: long term, short term, okay, and episodic. We will come to that part. So short term means related to a particular session. Like if user is asking a question, you are getting an answer that is stored into the short term memory, so that if you ask a follow up question, the short term memory is referred. So the whenever you get a final or a processed results, agentic AI system will also update the respective short term or long term memory, so that if any follow up question is asked again, it will refer to that memory. And not only in the memory you are storing that big answer, it is stored into the summarized way. So internally agentic AI system will summarize the answer and store it into the memory. Yeah. So this is more detailed drill down of the agentic RAG tool. Any questions up till this point? Any doubts? Any questions? Okay. Now, if you can see, agentic RAG supports various tools that we have seen. Okay. This approach is also called as, this is one of the use case. This approach is also called as a maker checker mechanism. Maker means you gather the results, you make the results, and then you check it, you verify it, and then generate the output, update the memory. So memory is very important part. So whenever we are building an agentic AI system, what are the factors you have to consider? You have to consider the factor first is hardware infrastructure. You should have a good hardware infrastructure. If you are building your own infrastructure, you should have GPUs if you are dealing with the open source LLMs. Okay, and the next thing is you should have a proper LLM, proper open source LLM or a subscription based LLM. If you're using your own infrastructure, you should use a open source LLMs. And the next thing is very important is your design should be, architectural design should be flexible. So your flow should be finalized for a particular use case. Whenever the user fires a query, how you will identify the intent from it, how the topic is identified, how you will classify that query into particular topic, and based on that topic classification, how the agentic AI system will call a different tools based on the topic, and then how it will generate the answer. Okay, how you will refine the answer using various algorithms, okay, or using prompt engineering or instructions to the LLM, all these things. Yes, I hope you are getting the things and we are moving forward. Any questions is there, please feel free to ask. Yeah.
Hello.
Yes.
Sir, I have a query. You stated that hardware infrastructure and memory is needed for implementation of Agentic AI. Can you state a simple Agentic AI application for that? What kind of hardware support? Say, for example, GPU.
Uh-huh.
What should be the speed of the GPU we are supposed to purchase, and the memory part, how much is needed for a simple agentic AI system? Say, for example, I'm going to implement an agentic AI for my own university. Okay,
Hmm,
and
hmm,
someone is asking queries related to all the things in my university. I want to implement a simple agentic
hmm,
AI system. In that case,
hmm.
what will be the hardware requirements and the memory requirements? Can you please state that?
It depends upon what LLM you are using. If you are using a small LLM, 1 billion, then you can run that 1 billion LLM into a 32 GB RAM also. Okay, or more than that.
Okay, but
32 GB is fine. But if you are dealing with big LLMs, you require a big hardware, big memory, more than that.
okay.
Yeah,
Suppose you said if
and
I want to go for
yes.
subscription based, okay, so I want to generate proper answers for all the queries. In that case, I'm going to
Hmm.
go for subscription.
Yeah, for subscription based, you don't require any hardware
Okay, okay,
because you're just you are using a OpenAI a subscription. You are getting a key from OpenAI, and then you are embedding that key into your code, right? In the environmental variables. Yes. So you
okay.
don't require a hardware for that because the model main thing is why we require a hardware for deploying the LLMs. If you're deploying a big LLM, you require a big hardware, big memory, big hard disk, maybe 2 terabytes, more than that. And memory also we require a good amount of memory, maybe 256 or more than that for smoothly running the things. But if you're using a small LLM, then it's fine. But only taking a memory and hard disk is not sufficient because LLMs is having their own weights. Okay, so CPU is not, even if you are using a multi-core CPUs, it is not sufficient to run that LLM if you are using a big LLM because all the weights you can't run on the CPU. There should be some parallel things you can because all the weights are loaded into the CPU and then some weights should be parallelized to the GPUs also to run the particular LLM.
Got it, sir. I see. If I'm going for subscription based, then the model will run in their server only. So
Yes, in
we don't.
subscription based thing, the model will not run in your premises. It will run on their premises. Like if you're using a GPT 5.4, which is the latest model, so it is not running on your premise, on your laptop. It is running on their servers in US. So you
Okay, then
will,
I can SQL database to store all the data which are available, or even a RAG model I can implement so that if there is any query related to our organization, it can go and fetch the data from there, so that I can
yes.
use it in that way. Is that correct, sir?
Yeah,
If
yeah.
I'm
If you're using a LLM which is subscription based, then a normal you can say configurations, not too low, but a normal configuration servers you can run and you can send the data to the LLM. You can implement the vector database and other things on your server, whatever on the server on which you are doing the experimentations, and then send the data through a API call to the LLM.
got it, sir. Got it. Thank you.
Yeah, yeah. Okay. The next part is multi-agent systems. So multi-agent systems, multiple specialized agents collaborate, if you can see, with having their own role, tools, and policies. Okay. So there are different patterns for that, like debate, critique, concise building, and hierarchical delegations. So these patterns can be implemented whenever we are building a multi-agent systems. So when we build a multi-agent system, if there are complex workflows, okay, like a big industry or a manufacturing industry, they are having a complex workflows. Okay, and if you want to simulate that workflows using multiple agents, in which the planning and executions, there are some human in loop interaction also. Like uh, we can't depend totally on the agentic AI system. There is something which is generated by the agentic AI, which should be verified by the user. That is called as human in loop. So that should be also implemented using workflows. And so there are different techniques that is a part of implementation. Like you can implement the multi-agent system using workflows using LangGraph. You can implement normal agentic AI system using LangChain. So there are different frameworks for the implementation. LangChain, Llama Index. For workflows, there is a LangGraph. Okay, so you can implement these systems. For workflows, I will suggest to study one of the good workflow uh, framework called as NAT9, NAT10. Sorry, NAT10 is the one of the workflow design. So you can just type NAT10, N at N. So you can see that things how the workflows will operate. I will show you, and then you can build your own workflows. So this is that link. I will post this link to you. Just have a look of it. So in this way, you can just study these workflows. Just a minute. Any question? What is reflected output? Sorry, what agent can do. Yes, we can. There is some question, Sanju Prince sir. Isn't it important to add a set of rules on what agent can do? Yes, we can add a set of rules. Definitely, agent will work on set of rules. Like you can tell the agent, okay, if the question comes, how to identify the intent, what are the instructions for it, and then how to identify that question into particular domain. There is another set of instructions for it, so that we can do it. So isn't it necessary to build a software or an agent itself to restrict agents which do not follow a set of rules ethics? Yes, we can do this with the help of guardrails. You can design a one guardrail agent which doesn't if anybody asks a question which doesn't follow any ethics, or any agent doesn't follow any ethical questions, you can create a guardrail agent. Definitely, just refer to this link. Okay, we'll come to that part. So in this way we can implement the main agent and its sub agent, and then they can collaborate with each other for generating the final response. So there is a delegation between them, handshaking between them, parallelism within the different agents, and then they generate the final answer. Now whenever we see a memory in agents, there are three kinds of memory: short-term memory, or basically two kinds, but short-term memory and long-term memory, these are two main important things. Short-term memory, it is stored for a particular session. Like if you ask a question, okay, and you get answer, you store that. Agentic AI system will store that particular question and answer into its short-term memory. As soon as your session ends, the short-term memory will go. Okay. Now, if you have seen in your chat GPT, if you open your chat GPT, you will see the questions which are asked previously, maybe 1 month before or 15 days before. That is a long-term memory, right? So long-term memory is also having a TTL. TTL means time to live. Like you can set a TTL of 1 month. After 1 month, long-term memory is also cleared. Now, why these memories are very important? Because the most important thing is conversational thing. So whenever you are building a agentic AI system, it should be conversational. What do you mean by conversational? If you ask a question, you get an answer. You can ask a follow-up questions based on your previous different kinds of questions, whatever you have asked. So it should be conversational. So for maintaining this conversational state or storing that particular question and answers and making the chatbot or agentic AI system more conversational, we need a short-term memory and a long-term memory. Okay. Now long-term memory is divided into three types. Semantic. Everybody knows the vector store, that is a semantic memory. Knowledge bases. Episodic memory means this is related to logs of past interactions, and procedural memory. So these are the two main kinds of memory which plays a major role in your agentic AI system. You can't imagine building an agentic AI system without memory. If you build an agentic AI system without memory, it will become a normal LLM. Okay, it will not be a conversational. You can't ask a follow-up questions and other things. Yes, just a minute. So there are various ways you can implement the short-term memory based on your session, based on your user ID. Suppose you build any um, agentic AI system for your particular website. So whenever user logs in, okay, and open that agentic AI system and ask any questions, it is stored there. It is stored into the short-term memory, questions and answers. Right now he logs out, the memory will go. Okay, in this way the short-term memory is implemented. There are various factors you can implement with the help of user ID. Session ID also is very important. And long-term memory, I have already given you the example of chat GPT. You will see all the questions and answers. You can refer um, to your questions and answers to a particular time period. That is a TTL, whatever the TTL it is set for 1 month, 2 month. There is another kind of memory called as cache memory. Now, what is the meaning of cache memory? Suppose you ask a question, okay, and you get answer. Now you ask another question in the different way, but the semantic meaning of that second question is same with the first question. So you can implement a semantic mechanism there or a semantic module which will check whatever the question, whenever any question comes, whether it is matching with the already asked question. If it is matching, it means that that question will not go to the LLM. It will fetch the answer from the cache memory, because hitting a LLM every time will increase the you can say billing. Okay, if you are using a subscription based model, every time you ask a question it will go to the LLM, and you know the LLM subscription models like GPT or other things, they are based on tokens. So tokens means words, or you can say words are converted into tokens. So how many words you send it to the LLM as a part of questions and prompts, and how many words the LLM will generate. Based on that, they will charge you the bill. So for every question, if you are sending the data to sending the question to the LLM and answer and asking to generate it, it's not logically right. There are some few questions which user can ask in a different way. The answer is the question is semantically similar with the previous few questions, and the answer you should not logically ask the LLM to generate it, because your answer is already stored into the LLM. So that is implemented using cache memory. So there are three kinds of memory. You can say short term, long term, cache memory. So this is not happening. Cache memory is not happening automatically. You have to implement it in your agentic AI system. So there are different models you can utilize for that. There is one of the good model called a sentence transformer model. You can search for the sentence transformer. If you go to the here, I will show you. So there are different models. You can utilize that model to build your semantic cache mechanism. Just refer this site. Many of you know this site. I don't know, but you can refer this. Okay, just a minute. Even Hugging Face is having their sentence transformer models. They implemented using, if you can see this. Everybody knows Hugging Face, right? You can utilize these models. You can use the Hugging Face models, Hugging Face website for utilizing the sentence transformer model. How to use it? It's shown as a sample code. You can use this. I'm posting you this one also. Okay. Now the most important thing is MCP. Now what is MCP? Model Context Protocol. Everybody has seen the tool calling, right? This is the first scenario. I will come to this scenario first. Now, what happens in tool calling? LLM will call a particular tool or a API. Suppose there are 5 tools, there are 5 APIs. So that 5 APIs LLM will call automatically based on the question. So these APIs are hard coded. Hard coded means the API link is fixed. Okay, and they are not aggregated into one particular one roof. Okay, so what the MCP will do? So it is an open standard. So there is a one server called as MCP server. There are different scenarios, like one is MCP host. What is the meaning of MCP host? MCP host means from where you are asking a question, like Cloudy Desktop, ID, AI tools. There is a MCP client and MCP server. Now, what is the meaning of MCP server? All these tools, suppose there are tools, so suppose this is a local file system, this is the vector database is one of the tools, this is the API. So all this is the weather API, this is the share market related data stored in vector database, and there is another web browser or a local file system related to another data. So all these tools are published into the MCP server. Okay. So you don't have to, so this is the standardized way in which under one roof MCP server, all the tools are published. Okay. I will give you one example. You have a Amazon website, you will have all the things of food and clothing, everything published under one roof. You don't have to, if you want to purchase a cloth, you don't have to go to clothing website and then search for that and order it. It's like this. Just as an analogy I'm giving you. So if there are 5 tools, you don't, here there is no publications of that tools under one roof. You have to manually, LLM will automatically calculate call that tool, and you have to manually configure that tool, right? But here what happens, all the tools are published under one roof, so that roof is called as MCP server, and that server will make a communication with the host or MCP clients. MCP clients are the past of as a part of MCP host. they will make a communication with the MCP client using MCP protocol, Model Context Protocol, which is designed by Anthropic only. Anthropic is one of the company, everybody knows it. So this is a universal adapter. You can say it's a universal adapter for publication of all the tools. Now one MCP client can make a connection to any, it is having one connection to the MCP server. This client is having another connection with the MCP server. You can make one MCP client making a connection with various MCP servers also.
Sir, I think it's a one-to-one relationship. Client and server, there is one-to-one relationship, not one-to-many. I think.
Yes, here you can see one-to-one relationship, but in the current research, whatever it is going, we can make a one-to-many relationships also. MCP client can make a connection with the more than one MCP servers also.
No, like I'm just taking the example, like suppose I'm taking example of a mobile phone. So
Okay.
my mobile phone has two SIM. So SIM is just a kind of like Airtel or Jio. So Airtel is just a client. So Airtel will connect with only the Airtel network and Jio will connect with Jio network. So similarly, because we hosted this client, MCP client in particular host. Host is basically anything like AI, anything
Yes,
LLM,
you are
right?
right.
We generated the NCP client, so NCP client will directly connect with the that particular server. Like maybe we can use any API tool like GitHub or any Gmail or any Drive. We can give this, but the connection should be one-to-one. But that client is only assigned for that server, like a client server like concept, like HTTP concept, like in networking. That is, I think, that is the concept of here
Yeah,
client and server. If I'm not wrong.
one-to-one, a one-to-one connection is there. I agree with you. But
Yeah.
suppose if you have, suppose you have a three tools. One is a weather app. One is you can say a share market app, and one another is another food market app. Now you can publish these APIs in one server, right? But if there are more than other apps that this MCP client wants to connect, then that app, that tools are published on another server, consider the case, then how this MCP client will make that connection to that server, right? So in that case, even if you see a one-to-one connection, this is the basic use case, but nowadays you can make a connection with more than one servers also.
Okay. So I
So the
didn't
meaning,
get, yeah.
so the
So yeah.
meaning is like what I'm trying to say is like if you have a means if your use case is such a case that if you have a three API tools, you publish and it is published on one MCP server, but if your requirement is on the more tools, then this MCP client should connect with the second MCP server. It can be possible in the current research, whatever it is going on.
Yes, sir. Got it. Yeah. Thank you, sir.
Otherwise what will happen, um, you will get access to only some particular tools like food app, share market app, and weather app, which is published here. But what about this? This is another tools which MCP client wants to access. Yeah, just want to say, convey this. But ideally this is the basic thing, like one MCP client will get connected with one MCP server and having these scenarios. Okay, so basically it is a universal adapter, and you have to publish that API tools there, and then MCP client will get connected with it. What is the usefulness of this? Anybody can tell? What is the usefulness of this? You can build your agentic AI system based on whatever the universal tools are there. If they publish that tools for fetching their data on the various MCP servers, right? So you can get connected with maximum grounded data, and you can build your agentic AI system based on that grounded data. Okay, I will give you one example for this. We'll come to that benefits and other things afterwards. Consider that there is a MCP use case. We will see that a user wants to book a flight using AI assistant powered by MCP. So this is your AI assistant, which is having a MCP client here itself, in the AI agent, and this is the MCP server. So all the tools are there here. So search flight is one of the tool, is published here. Okay. Then book a flight is another tool published here. Okay. So first, there is a first step is connection. The AI assistant, this is the AI assistant, or you can say user here, makes a first connection with the MCP server with the help of AI agent. Okay. And then user asks a question to with the help of AI assistant or AI agent, what tools do you have available? Okay, so it will have two tools published. One is searching the flights and booking the flights. Okay, so the AI agent will get it know, okay, there are two tools, search flights and book a flights. Now what the AI assistant or AI agent will do, it will say that please search for a flight from Portland to Honolulu. There is a two places, Portland to Honolulu. So that request will go to the MCP server, and AI agent will identify, it will identify the tool on the MCP server, which is a search flight, because search flight will find the flights between two different source and one source and one destination. So what the AI assistant will do, AI assistant, or you can say AI agent, it is having a LLM and all that scenarios, LLM, RAG, everything here. So it will identify first the search flight tool, and it will search the flights from Portland to Honolulu. Now what this search flight tool will do, the search flight tool will find, there is a one API connected to that particular tool. That API will search the data from Portland to Honolulu, get extracted all the data, pass it to the AI agent. So first step is executed, that the flight is searched. So there are suppose 4 flights in a day from Portland to Honolulu. So that flight searching is done by the search flight tool, which is published here, because that tool is having connected to one API. Now API means application programming interface, which fetch the data, grounded data from particular location and send it to the AI agent. And then that search flight data with origin and destination, Portland and Honolulu, that there are 3 flights that will come to the MCP server, and then what the MCP server will, it will work as a wrapper. Now what is the meaning of wrapper? It will pass that flight information again to the AI agent. Now what the AI agent will do? AI agent will take the data, JSON data of 3 flights, which is from Portland to Honolulu, and then again call a second tool, which is called as booking flight. Okay. Now what the booking flight tool will do, it is having a booking API. So it will receive the 3 flights data from search flight and to AI agent. Out of that 3 flight, if user selected one of the flight in the morning from 8 to 10, that data will go to the booking flight data, a booking flight tool. Booking flight tool will call a booking API. Okay, and then booking API will book the flight from Portland to Honolulu from 8 to 10, 8 a.m. to 10 a.m. And then confirmation message come to the AI agent. So if you can see in this scenario, there are 2 tasks, searching the flight and booking the flight. Okay. So first, it depends upon the user query, which tool is called. If initially, if user will ask the MCP server what tools are available, it will say search flight and book flight. Then it asks a follow-up question. Please search for a flight for Portland to Honolulu, because he is interested in doing a booking. That's why he is asking a question. Then it will come to the search flight tool. It will fetch all the 3 flights data, send as a JSON to this agent. Out of that, it will select one of the flight, send that data to the booking flight tool. It will call the booking API. So everything is automated here with the help of AI agent. So there are two subtasks for a main task. One is search flight and book flight, and all the tools are published here. APIs are connected automatically. These tools are also called automatically by the AI agent based on the query. So the main use of MCP server is publications of the tools at a centralized place. I hope you got the things, which is not possible in this case. It is not published centralized way, right? Okay. So there are MCP core components. Host, everybody got what is the meaning of host. Okay. Client, everybody got it. Server, everybody got it. Okay. Tools, everybody got it. What is the meaning of tools? Tools means which is called, basically these are APIs or vector database or anything through which we are getting the grounded information. And resources. Okay. Resources means they are basically read-only data items or documents that an MCP server can provide. Okay. So like database records, log files. Some log files are generated on the MCP server. You can MCP client get access to the log files. Some database records also it can get access. JSON data. I already told you that whenever the flights are searched, the JSON data will come to the MCP server. So that JSON data will pass to the AI agent. So that the JSON data is also one of the resource. So you have to configure what resources MCP server can handle. You have to publish it, or you have to tell whenever you are configuring the MCP server. So MCP core server, you have to configure it with the help of code, Python code, whenever you are building such components. And the prompts plays an important role. Maximum things are revolving over prompts. What you are asking, how you are giving the instructions to the agent, step by step instructions, algorithmic way, how you are giving the instructions, the agent will act accordingly. Okay. Benefits of MCP: dynamic tool discovery. AI agents can automatically discover available tools with the descriptions from the server. Now, what is the meaning of descriptions? Now you will get one question in your mind. If I have a local file system here as a tool, or you can say one of the API as one of the tool, how the AI agent will automatically detect that tools? It depends upon the description. You have to give a description of the tool in the form of instructions. What the tool input is there, which input the tool will take, which output the tool will generate. So that is published on the MCP server, and this information is passed to the AI agent. And based on that, it will call the particular tool. So tool calling is also called as function calling in your layman language. Okay, everybody knows a function calling in C, C++, Java. Okay, when you call a particular function, you have a suppose addition function having two parameters. Okay, when you call that function, whenever you pass that two parameters in the form of integer, it's supposed to take a two integer parameters and generate the output as an integer only. So its return type is integer, right? So when you call this add function, whenever you make a call of add function, you're calling add function with two integers only. If you call add a function with two strings, it will not get called, right? So it means that function calling in our normal case also depends upon what the input you are providing, what the output it is generating, and the description of the function. In the same way, the tool calling will work. How you have to tell to the MCP server what the input the tool will take, what the output it will generate, and what is the description of that tool. Based on that, the agent will automatically call that tool. But naturally, you have to give instructions to the agent when to call the tool. When this kind of input comes, when this kind of situation comes, you have to call this tool. Okay. So that dynamic tool discovery is done here. Okay. Just a minute. Flexible integrations. This is very important. With integrate once approach, agents can adapt easily even when APIs or tool change. Now, what is the meaning of this? Suppose the case that if there is a one API here, weather API, it changes. It suppose change in the future. Just you don't have to bother about it. You don't agent don't have to change their code and change the API configurations in their code. Only thing is whenever the API change, it has to publish that API here. Okay, that's it. Everything will be automatically called using MCP. So it provides the standardized security measures with the help of MCP server. It says LLM interoperability. What is the meaning of interoperability? MCP works across multiple LLMs. What is the meaning of multiple LLMs? Every client, or you can say agent, this is the part of agent. MCP agent don't come under MCP server. MCP server is different. Agent come here. So every agent is having their own LLM. Suppose this is GPT 5.4 LLM agent is using or client is using. This is the open source LLM Llama. This is the Mistral. So you can make a connection to the one MCP server or maybe a multiple MCP server based on your use case, right? Yeah. Yes. Any questions up till this point? Everybody got this MCP use case or any doubts you have in this? Tool calling, what do you mean by publications of the tools, how they are called, everything? Okay, fine. Now, whenever we are dealing with MCP, it is based on tool calling. Like you are gathering all the tools at a centralized place and publishing it. So it acts as a universal adapter. But whenever we are dealing with A2A, now there is another protocol which is agent to agent protocol. Okay, now what happens in agent to agent protocol? One agent can do a communication with another agent. Okay, so this agent is having one MCP, this agent is having another MCP server, and then they both can interact with each other. That is possible using A2A protocol. Okay, one of the research I already told you which is going on, like bypassing A2A, that one client is getting interacted with multiple MCP servers. In that case, it will be a part of A2A. Okay, so it will be a part of A2A because what A2A do? A2A basically provides the standards or connections how to do a handshakes between two different agents. Suppose this is your one particular agent designed for one particular task having their own MCP tools published. This is another agent, but the complete goal can't be achieved with the help of one agent, and they can do a handshake, they can exchange the data, they can coordinate within each other and then perform the particular task and achieve the goal. So A2A protocol deals with the agents, MCP protocols deals with the tools, publications of the tools at the centralized place. So you will have in MCP different benefits. Already I told you. Security wise, it is safe. Many software companies who are doing research or dealing with the agentic AI system, they are working on this MCP, and also they are developing their use cases based on MCPs because it is flexible and easily scalable. And also they are using A2A protocol. So what are the benefits of A2A? Enhanced collaborations. So agents will interact with each other different vendors and platforms. If there is a one agent of Microsoft created by Microsoft, one agent created by Google, they can interact with each other using A2A protocols. Model selection flexibility. Each A2A agent, they can decide at runtime, or you can say we can predefine it which LLM they can use. Every agent is having their own LLM. It's not the case that this agent will always use this one LLM. You can configure one LLM for this, a different LLM for this, based on the use case. And built-in authentication. Authentication means, suppose you build this agentic AI system and deployed it in your organization, you can fix the authentication mechanism for this. This is deployed in another organization, and then who can access both the systems? That authentication and authorization you can configure using A2A protocol, so that a user from this organization can also access or pass the data to the another agent on in the another organization. Same for from here side also. So this protocols plays an important role in terms of authorization, authentication, and other handshaking signals. Just a minute. My voice is audible to you because I'm not getting any voice from you. Okay, fine. Now A2A use case we will see. Just have a glimpse of this diagram, what you can get from this. Just go through it. I will explain. See, suppose there is a travel agent, or you can say you developed a different agents. This is a travel manager agent. Okay, there are other agents. Okay, and you ask a question. Please book an entire trip to Honolulu for the next week, including flight, hotel, and rental car. Right now, flight booking is done by, we can't see here. Okay, there is a travel manager agent which will, whenever you fire any query, it will first accept that query. Okay, and this is the agent card. Okay, so where all the agent information is available, and then this, all the other agents are connected to these agent cards. So every agent will do their task. So this is called as orchestration of travel agent or any other agent. Like you ask a query, and if there are subtasks, every agent will take that task. Like currency exchange agent will do its task. Activity planner agent will plan the activity for your travel. Okay, and then these agents are published on the agent cards. So there will be an inter-agent communication. You can have a one arrow also from here to here if it is required based on your use case. So there is an inter-agent communication. There is a communication between two or more agents, and then they achieve the common goal by executing their different tasks using A2A protocol, and then they generate the consolidated response. Okay, so if you can see, if user asks a question, please book an entire trip to Honolulu for next week, including flight, hotel, and rental car. So there are 3 steps here: finding flights, book a hotel, rent a car. So maybe these 3 steps can be handled by different agents, and then they coordinate and generate the final response. So in this way, A2A protocol will work for various use cases. Yes, any doubts up till this point? Hope you are getting the things. Up. Now the future trends. So whenever we see in the future AI agent development, there are 3 things. Edge AI. Edge AI means there will be edge devices in which the processing of the local data processing for the real time is done. Okay, so that why it is done to reduce the latency. Okay, nowadays latency is very important. Sometimes what happens, you ask a question to the agentic AI system, you will get a response having some latency. Okay, because processing matters, how you process the data, where you are processing the data. Okay, whether your what is the architecture of your system, whether your agentic AI system is residing on the same server where the processing is done, all these things. But in future there will be edge AI devices in which the processing of the data will be done at real time, which will reduce the latency. So for two important things are there which is very important in the future: latency and accuracy. And then the second thing is autonomous learning. Okay, self-learning or autonomous learning using different machine learning techniques. Okay, like based on the use case, like if you have an anomaly detection use case, how you can implement the machine learning algorithm into your agentic AI system, how you can plug it. Okay, so that you can detect the anomalies. Agentic AI system will detect the anomalies. See, agentic AI system is based on LLMs, and LLMs works on unstructured text nicely. But if you have a structured text and you want to do some predictions, recommendation systems, then you have to plug your machine learning algorithm based on your data, structured data, into your agentic AI system. So how that machine learning algorithm will be plugged into your agentic AI system, that will be your next steps. Because nowadays people are running over only generative AI. Okay, I fire a question, I get answer. But what happens if you are building a system like anomaly detection, which is based on structured data, right? So you you can't use the LLM in that case. So not every time you have to use the LLM, right? So that is one use case with advanced machine learning, how you can plug the machine learning algorithms into your agentic AI system. Also, self-adaptation, reinforcement learning, how you can implement in your agentic AI system. AI for sustainability, intelligent optimization of energy and resources across various industries, how you can do it with various techniques, how you can implement. Again, here the machine learning will come. So machine learning will not go even if the generative AI will come. Even if the generative AI is in the picture. Okay. So what will be the future of AI agents? Future of AI agents is based on these three things: MCP, A2A, and NLWeb. NLWeb is natural language web things, and how we can use these protocols to make our system more scalable, more accurate with less latency. And how the second is how you can tightly integrate your enterprise data workflows, how you can automate the workflows on a scalable level to make it more robust, your agentic AI system. That will be the next steps. And the most importantly is third point is safety monitoring and governance, having ethical things implemented in your agentic AI system. And also it will be explainable AI. So nowadays, if you can see, explainable AI is one of the most research area everybody is focusing. So why the AI system is behaving in that way, why it is generating the answer in that way. So you can implement the explainable AI module in your agentic AI system, which will give the answer. Okay, I will give one example. Like whenever we detect the anomaly detection, suppose we use the isolation forest algorithm. Okay, we have the explainability why the algorithm have extracted the anomalies based on these features. Okay, so that is called as explainability. So in the same way, explainable AI will come plays a major role in terms of scalability, accuracy, why this system is behaving in this way. Now, nobody is thinking nowadays that why the system is behaving in this way. We can't guarantee that AI is giving the right answer. It should be explainable. So you have to plug in your explainable AI module in your agentic AI system. Why the LLM is generating the answer in this way only? What are the different factors responsible for that? Okay, in this way, these areas will be very important uh, in the coming days, and based on these areas, the more scalable, accurate systems will be built. And everybody knows that after maybe some work has already started on humanoid robots, and naturally humanoid robots will use the LLMs as the one of the knowledge base sources, but there will be more research going on the humanoid robots, how we can use humanoid robots for cognitive reasonings and other things. So agentic AI will also play a major role in the humanoid robots in the coming days. So thank you so much. If you have any questions, I'll be happy to answer.
Sir, going back to initial slides,
Okay.
there was some error measure that you were talking about, correct?
Yes,
While
yes.
it corrects it.
Yeah.
So, what kind of error measurement does it use?
Yeah. So there are different error measurements algorithms we can implement based on our use case. Okay. So there is a one mechanism, one standard called as Rouge mechanism. So using that Rouge mechanism, we can implement that Rouge mechanism as an algorithm and measure the error rates, like how much answer or how much tokens are LLMs are generating, they are matching with the grounded truth. That is one of the measure. Second thing is how much answers which are matching with the actual answers. There are different measures you can implement with the help of different algorithms, so that you can get a more accurate answers which you are expecting.
Thanks, sir.
Yeah. Any other questions?
So, like,
Yes.
so MCP is like, like client server protocol, like HTTP,
Hmm. Hmm.
right? So here, if you are talking about the security in NCP, so is there any kind of security protocol or any kind of research is going on regarding those? What are the different, like
Hmm.
authentication and trust verification in NCP, right? That is a called OTP kind of authentication. So how, like, because if they are
Hmm.
calling the third party API or third party any tools, so there
Ah,
may be like, so this kind of is there any kind of research and any kind of development going on in NCP protocol?
yes. Currently,
Yeah,
whatever the tools we have, suppose your company has a three tools, and you published that tools as on the MCP server. Okay.
yeah,
Now, what who will like, and I am having a MCP client. Okay.
yeah,
Now, who is the or you can say to whom person we can authenticate and authorize based on the access tokens, JWT tokens, or see, the main thing is tokens.
yeah,
Okay, there are different types of tokens. Suppose
yeah,
you log in into any website. Okay, there is a one token generated if you are a valid user, right?
yeah.
So in the same way, you can implement different token scenario, uh, and data tokens, security tokens, header tokens, and that tokens will play a major role in authentication and authorization, so that the particular authorized user will log in into the particular system and then call a tool which is published on that MCP server.
Okay, okay, yeah,
Yeah.
got it.
And
Got it.
also on the backend side, like suppose your company is working, you publish suppose 3 APIs and you publish that APIs onto the server. So how to maintain that tokens, when to refresh that tokens, when to generate that tokens, all these things can be done by the MCP server in the backend.
Yes.
Yeah.
Yeah, thank you. Yeah, I got my answer. Yeah.
Yes. So main thing is authorization and authentication. See, the basic concept never goes. Like we know that website is having authentication and authorization. Same concepts we can apply in a different way, in a different flavor.
Because data is very much important if you are if you are applying this kind of multi-agent system in medical data, like some kind of, you try to make uh, any kind of humanoid robots where there is some dealing with the clinical medical data. So that
Mm.
time, this data security and authentication, if you are
Yes.
someone is going with the robotics kind
Yeah.
of surgery, so
Hmm.
that time is much
Definitely.
very much integration. In the IoT concept, there is a concept of POF that is called physical unclonable function. So that is the
Hmm.
hardware level security. So hardware level security that cannot be break, but this MCB is a similar kind of internet protocol. So where
Yes.
it can be vulnerable, we can hack it, and we can also
Yeah. Yeah.
because recent some kind of phase last year is there is a war is going on. So some kind of data. Uh, I'm not
Hmm.
going with that political things, but
Yes. Yes. Got it.
this
Yeah.
article,
Yeah.
yeah,
Yeah. So we with the
yeah,
proper mechanisms like authentication
yeah.
tokens, authorization tokens, headers, data tokens, and other tokens we can implement, and when to generate it, uh, when it will expire, you can set the expiry period for that, so that a proper user, authorized user, can access that agentic AI system, and also internally access or call, or agent will call that particular MCP server tool based on who is accessing that agent. Yeah.
Yes, yeah, got it. Yeah.
Any other questions? Hmm. Okay, then. Thank you so much. If no questions are there, thank you, Nilesh sir.
Thank you, sir. Thank you for the wonderful session. We sincerely appreciate your valuable time and insightful as a guest speaker. It was a great learning experience for all the participants. Thank you. Thank you so much, sir.
Thank you. Thank you so much. Thanks.